Welcome to The Explainer. Today we're diving into a massive, fundamental shift in how we actually understand the markets. The core theme we're unpacking here is how the analysis, and really the validation of financial market data, is undergoing a total evolution. For decades, we've relied on the exact same basic approaches to test our trading ideas. But the sheer volume and complexity of modern data, it's literally forcing a complete rethink from the ground up.
Okay, let's dive into this. How can we truly trust the financial models and the data driving our markets right now? That is the central problem of data integrity in financial analysis. Think about it. If the raw data feeding our models is flawed, or if the way we're measuring success is just looking at the wrong things, then our entire foundation is completely shaky. Today, we're going to explore how massive institutions like the Bank for International Settlements are tackling this, and how cutting-edge frameworks are completely changing the way we look at price charts.
So, to understand where we're headed, we kind of have to establish where we currently are. The traditional concept of backtesting is perfectly captured by this analogy from our research. It's exactly like a doctor diagnosing a patient based on their medical history and their current complaints. You're basically looking at what happened in the past to try and figure out what might happen in the future. Backward-looking performance metrics play a huge role in how we evaluate any financial strategy today. And when we do that historical check, we usually lean on these classic traditional metrics. The Sharpe ratio to see if the risk was actually worth the reward, the profit factor to weigh your gross profit against your gross loss, the max drawdown to measure that terrifying deepest peak-to-trough drop. Now, don't get me wrong, these are helpful outcome-based metrics, but here's the catch. They are absolutely only as good as the raw data they process. If the underlying data structure is misinterpreted, these metrics just give you a false sense of security. Which brings us to this incredibly powerful quote from the Srbmpr research framework. Prediction without structural evidence is considered an assumption. I love that. It perfectly sets up the massive pivot we're making today. We are moving away from just trying to predict outcomes based on a handful of indicators and moving toward the rigorous, unbiased observation of raw data and structural evidence. Here is our roadmap for today. 1. The art of backtesting. 2. The data integrity problem. 3. Machine learning for validation. 4. The Srbmpr paradigm shift. 5. Analyzing raw market behavior. And 6. Validation and sequence logic. All right, Section 1. The art of backtesting. Let's look a bit closer at why just relying on those backward performance metrics is becoming a massive bottleneck in modern finance. Traditional data validation techniques, they really struggle with high-frequency financial data. The graphical method, literally just eyeballing a chart, is hugely vulnerable to human oversight. Conditional if-then controls, they fail the very second there's a structural shift in the market. Threshold-based warnings trigger constant false alarms, and cross-referencing data manually is just incredibly time-consuming. These traditional methods simply cannot scale to meet the demands of modern markets. Moving on to Section 2, the data integrity problem. And this brilliantly illustrates what happens when the data we're feeding into our backtests is just completely misunderstood. Take a look at this U.S. Secured Overnight Financing Rate, or SOFR, chart from the third quarter of 2019. Look at that massive spike. To a standard threshold-based warning system, that looks exactly like a data error, a false negative. But it wasn't. It was a true outlier. Validating a data point like this requires deep, contextual knowledge of the market. Without that context, you might accidentally scrub out the most important data points in your entire backtest. Section 3. Machine learning for validation. So how on earth do we fix this at scale? Well, central banks, like the Bank for International Settlements, are actively modernizing this tedious validation process. Their researchers have proposed a highly automated workflow, which we've got here in 4 key steps. Data input and gap checking form your foundation. Then dimension reduction isolates the key features that actually explain the target series. Finally, algorithms predict values and analyze the errors. By understanding contextual relationships across thousands of time series, this machine learning workflow effectively filters out the noise and the false alarms. It basically acts like a human subject matter expert, but at a massive computational scale. Which leads us to Section 4, the Srbmpr paradigm shift. Now that we really grasp the need for pristine, context-aware data, we can look at the ultimate evolution here, the Srbmpr framework. Traditional technical analysis relies on indicators to constantly ask, where will price go? It's entirely outcome and prediction focused. But SRBMPR, which stands for Structural Raw Data Behavior Methodology Price Research, asks a completely different question. It asks, what is price expressing? It is entirely focused on process and observation, relying solely on historical measurements. It treats the market as a continuous behavioral process, not some random guessing game.
Section 5. Analyzing raw market behavior. To truly answer what price is actually expressing, SRBMPR completely abandons conventional indicators. 80,835. That is the exact number of data points analyzed in a standard historical dataset just to build the observation layer. But here is the fascinating part. If you run a backtest using a raw 1-minute data file for, say, Bitcoin or gold, the engine isn't looking at opens, closes, candle bodies, or wicks. It completely ignores them. It only cares about pure raw data extraction, specifically isolating valid high-to-low structural transitions. Nothing else. That is the intense scale of data integrity required to stop predicting and start actively observing.
Let's move to and see how this builds into their actual methodology. This is the SRMBPR research loop. Step 1. Preserve the historical data and context. Step 2. Identify the zero cycle, the absolute origin point. Step 3. Extract the behavior sequence. And during this precise extraction, the engine is actually calculating exact metrics from the raw data. It counts exactly how many high-low sequences complete and how many fail. It maps out quantity transformations, simulating the path of starting with a micro quantity and tracking exactly how many transitions are required, logging every add point and every safe point along the way. Step 4 is rhythm measurement. It is a completely data-driven, highly mechanical extraction of market memory.
Section 6. Validation and sequence logic. So how do we actually validate these extracted sequences in a backtest without human bias creeping in? It comes down to their golden touch rules. Low must touch low, high must touch high, high to low must be touched, left side low must be touched. The overarching philosophy here? The market moves only by contact. If a level hasn't been physically touched by price, it is not valid yet, period. Contact creates the context, which creates the behavior. It's binary, it's totally measurable, and it completely removes all the guesswork. So, the crucial point is how all of this actually translates into execution. Because they filter out the noise and focus purely on raw high-to-low structural breaks, the whole process becomes entirely discretionary-free. Left-side memory dictates right-side development, and before it even enters execution mode, the engine runs strict validation rules. For instance, the first 10 high-low transitions might face a 5% exposure validation. If the sequence matches, it executes. If it mismatches, it locks. The final output report you get doesn't just boast about profits. It gives you the raw facts, the asset, time frame, total high-low transitions, completed versus failed sequences, average transitions per completion, and the precise quantity growth path detailing every single add and save count. It's all based on a single locked run of the rules. And that brings us to the core takeaway of this explainer. The entire evolution of backtesting, whether we're talking about central bank machine learning algorithms or advanced frameworks like SRMBPR, is moving us away from a paradigm of assumption straight into a paradigm of pure observation. If we stop forcing our predictions onto the data and start actively observing the raw behavior of structural sequences, what hidden market rhythms will we discover next? It's a completely fascinating question and one that is fundamentally changing how we analyze financial markets. Thanks for watching.